Hi, I'm Rich from Inside HPC, and I'm here in Hamburg. We just wrapped up the International Supercomputing Conference. My guest today is Nicolas Dube. Nick is a data center efficiency strategist for HP, and he's also a member of the Green Grid. So we're here today to talk about data center sustainability. Nick, what do we mean when we talk about that?
All right, so sustainability is basically a whole broader focus than energy efficiency. If you look at the last decade, basically, PUE, which is now a commonly known metric, stands for power usage effectiveness, really drove the data center efficiencies from the high 2 and 2.2s to now best of class. You can basically get a PUE if you're running on free air, cooling, etc., about like slightly sub 1.1. So the best data centers and the new kind of pod deployments that we'll see in the next years to come will have PUEs in the 1.07 kind of range.
Okay, so the closer you get to a 1-to-1 ratio, that would be perfect, right?
Well, yeah, basically a 1-to-1 ratio is well, it depends. Basically, if you're looking at a PUE of 2, it means that you're spending as much energy to power and cool your computer than for the actual computer itself.
Oh.
So as you're driving from a PUE of 2 to 1.5, 1.3, 1.07, it means that basically at 1.07, you're spending only 7% increment over your actual computer electricity consumption.
Okay.
But going on from that, basically you see that it's kind of an asymptotic kind of curve, and there's no way we can reach the 1, basically where the actual computer power usage.
Yeah.
So while PUE really drove that kind of energy efficiency improvements across the data center market, not just in HPC, basically you look at the service providers, all of the cloud and large infrastructures, data centers, it really improved. However, we're now at a point where a 20% improvement on the energy efficiency of the data center of a PUE of 1.07, I mean, it means you'll get roughly at 1.06, so that's really small.
Yeah.
So we need to look at the big picture, and the bigger picture now is like somebody from Intel, one of my colleague from Intel says, we need to focus on the 1, so computer power usage. So how do you split?
Yeah. The numerator, not the denominator? Or?
Yeah, basically.
Yes.
So actually, it's the denominator,
It is the
which is
denominator.
the computer power usage.
Okay.
So if you look at it, basically on the typical computer today, 50% of the power will go in the processor. About 20 to 25% of the power will go into the memory subsystem.
Yeah.
And about 8% on the chipset, about 8% on the network interface chips, some MISC logic, and then you have the power supply efficiency and the fan power. So some people think that the power supply efficiency and the fan power account for a big portion of that. But we're now at a point where power supplies are like 94% efficient. So, I mean, all the big vendors are looking at ways to do high voltage DC power distribution to the nodes and things like that. So we'll say maybe 2 to 3%, things like that. Some people are also looking at, I've been asked recently, could you remove the server fans from my servers so that I would save that electricity? Well, that's heard that a few times. While it may seem like an interesting idea, basically using the data center's air moving capacity to flow through the servers and removing the server fans. So you'll save roughly 1 to 2% on the server side.
Yeah.
If you do it, if you get a vendor to agree on that, but that's kind of the tricky part.
Right.
But, you know, on the grand scheme of things, you'd actually have a higher PUE because the fan power is in the denominator, not in the numerator.
Oh, right.
So, but on an overall total energy consumption, you would actually be slightly lower.
Okay. So there we sit. Where do we go next then? Where are we going to get gains?
So the thing is that we've optimized pretty much all the big things that could be optimized, and the small optimization either on the PUE side or on the computer power. And I'm not talking about like the new architectures like GPUs that gives you more flops per watt, vice versa. I'm just talking from a pure power usage perspective. Basically, we're in the small numbers. So you want to look at a data center in a whole much more sustainable way. It's not so much just about efficiency anymore. It's about what is the whole data center energy footprint in its environment? How much water is that data center consuming?
Okay.
And for instance, what is the carbon footprint of that data center depending on the electricity source?
Okay, so it's overall impact on the planet, that kind of thing.
Yeah,
Okay.
basically.
Yeah.
So, for instance, I'll give you an example. Say you'd be looking at, say, like removing the fans on your server and save 1 to 2%.
Yeah.
Well, you'd much rather deploy your data center in a place, in a geography, in a climate that's cold. So basically, and that's what that new metric that basically the Green Grid has just introduced 3 new metrics. So ERE for energy reuse effectiveness,
Okay.
WUE, water usage effectiveness, and CUE for carbon usage effectiveness.
Okay.
So let me get back and start with ERE.
Okay.
So basically, you'd be able to use the computer as a giant heater. So by recovering the heat produced by the components and doing district cooling or providing warm to hot water to or to industrial processors or things like that, you're actually offsetting the computer's electricity footprint to do something useful with it.
Sure, sure. And there's always been stories about Cray machines being used to power the office building next door, this kind of thing, right? To heat them up.
Well, what's interesting is that like there's more and more talks about liquid cooling, for instance, today. And because, you know, moving heat using liquid is just a whole lot more efficient than moving heat using air. Well, the revolution is really not in liquid cooling, because liquid cooling has been around forever, right? Remembering the first Cray machines.
Sure.
So what the market is considering today is basically how do we commoditize liquid cooling, or and how do we get in a production mode that it becomes something that's a whole lot more mass market than some of the architectures we're looking today.
Okay.
Having that, basically, that would enable a data center to not require water to go in the 8C kind of range, but at much higher temperatures. And then also the output water coming from the computer could be potentially in the 50, 60 centigrades kind of range. That's the kind of water temperature you can use in a cold climate to do district heating. And then basically your computer power is just a giant heater. And so you're completely offsetting its energy footprint on the grid.
Okay, so that would be that metric. Okay, you want to reclaim energy as best you can. Then what's the next one?
So the other metric is basically that just got introduced at the start of this year is water usage effectiveness.
Water usage effectiveness. Okay.
So why do you care about the use of water in a data center?
Yeah.
So it's kind of not that complicated, but basically people are using what's called evaporative chillers to do cooling. Evaporative chilling is, from an energy consumption perspective, is a whole lot more energy efficient than using compressor cooling to do the chilled water loop.
Okay.
However, when you're leveraging the phase change reaction that happens when water evaporates.
It cools things off when it evaporates.
Yeah, exactly.
Okay.
Just like you cool your body by sweating. It's the same principle.
Okay.
So, however, doing that, you'll be evaporating gallons of water in the atmosphere. So the question comes is that if I'm in a sunny and dry climate, for instance, where I'd be able to generate electricity using solar power, is it more eco-friendly or sustainable to consume like slightly less power to generate my cooling because I'm evaporating water in the atmosphere, or vice versa? And that's where the whole sustainability discussion happens, and it's really site-specific.
Okay. So that's the second one. What's the last?
And so the third metric is carbon usage effectiveness. And basically, well, still it's not a perfect metric, but the goal of that metric is to track the carbon content of the computer itself. You've probably read about like the built-in carbon of servers or that table or things like that.
Sure.
That's one part of it. But the bigger part is basically the carbon content of the electricity source for that data center.
Oh, okay. So it matters where the electricity came from.
Oh, in a big way. Basically, from a study that was published on the UK Post, and that supported the new carbon tax that just got enacted as of this January in the UK, and so that study I kind of like because it's very independent. Carbon, a kilowatt hour of electricity produced on coal emits roughly 1,000 grams of CO2 equivalent per kilowatt hour.
Okay.
If you produce that same kilowatt hour with hydroelectric power or wind power, you'd be in the range of 5 to 10 grams of CO2 equivalent. So there's a 200 times magnitude between coal power and renewables.
Okay, so why isn't wind power or hydro, why isn't it zero? Where are these grams coming from for that?
Good question. So basically what they did when they did this analysis is that they analyzed the full carbon footprint, for example, for an hydroelectric facility, from construction to demolition.
Oh, okay.
So you need to account.
It's got lifetime karma going
Yes,
on. Okay.
you need to account the fuel that goes in the dump truck to do the dam and everything.
Okay.
So that's kind of like the embedded carbon content. But obviously, hydroelectricity, when it's in production, emits roughly nothing.
Yeah.
It's zero carbon emission.
Yeah. Well, what about like if I'm releasing water temperature that's higher than the environment? I could be doing damage like that, right? So this one, there's no measure for that kind of thing, impact.
So that's an interesting one. There's people that are looking, for instance, at basically doing water cooling to their data center, and then releasing the energy in lakes or in rivers or in the sea. And obviously, there's going to be a local environmental impact if you do that.
Right.
So you need to be really careful with the flow rates of the river and things like that.
Okay.
To date, it's really something that's hard to account for.
Okay.
I would answer to that basically the way you would want to do it is as you're sending back the water to equalize, you want to recapture as much as the heat as you can to do, like I said, processes or heating or things like that.
All right, so you've got that then. You've got these metrics. Why would a company, for instance, care about the carbon footprint? I mean, is it just because they're going to get taxed more that they got to start paying attention to this?
Well, as of today, basically, except in the UK, there's no carbon tax.
Okay.
The UK has just started it, and we're really like ahead of pretty much everybody else in doing that.
Okay.
So if you're a large service provider, for instance, and you're building a data center in the U.S. in a region that's powered by coal, as of today, it's actually much cheaper to do that than to build in some regions that are hydroelectric powered.
Okay.
Like to give you some example that I had computed some time ago, say you're building a 20 megawatt data center, and instead of building it an hydroelectric power in some states, you'll pay around like 12 cents a kilowatt hour. You're moving to a coal state, you may pay in the order of 6 cents or something like that. I mean, this accounts to annual savings in the range of like 10 millions a year, just in electricity costs.
Okay.
So even if you'd apply today's UK carbon tax, you'd pay like 10 million, about 2 million in tax. And so you're still 8 million profitable for using coal power.
So cheaper to pollute in the current structure?
Today, yes.
Yeah,
but
it's terrible.
But the big question is, however, is like looking at longer term, I mean, we're seeing more and more extreme weather events in North America, for instance.
Yeah.
And someone could make an argument that within the next 5 years, we may not see a cap and trade or a carbon tax in the US. Within 10 years, well, maybe. I mean, really, nobody knows.
Yeah.
But there's a business, Chris, for somebody building a large data center that at some point over the amortization period of the data center, there may be a carbon tax that will be legislated and enacted.
Okay, so what is that? What is that? When you build a data center, you have to think about 20 years out, something like that?
Well, most data centers will be, and it really depends from company to company, but you'll be looking at 15, 20, sometimes 25 years amortization. Yeah. This kind of whole equation changes with the pods and things, but that's, you need to pay for the facilities anyway and the mechanical. Okay,
these are big business decisions with a lot of factors involved. Now, you say you have these metrics, right? And you're going to do it. This is a 4-dimensional thing, right? I mean, so if I did 2 out of 3, what could I still say? I'm Mr. Green, sustainable guy.
Well, you'd be greener than if you do only one, right?
Yeah, right.
Ideally, you'd really want to do all 4 of them because it's really a multivariable equation.
Okay.
And I mean, and why do you want to have metrics? Is basically in order to improve on something, you need to be you need to have a good metric that's you can apply across the range, and anybody can try to shoot for that. And that's basically the goal, why you want to have those complementary metrics. And so we're now at 4. PUE, ERE for energy reuse efficiency, carbon usage effectiveness, and water usage efficiency, which gives you the whole portfolio.
So where's Green Grid at with this now? Is it in proposal stage? What are you guys doing?
So basically right now, the Green Grid has been historically driven mostly by vendors, large service providers, and everything. And recently, there's been agreements made with the top 5 to collaborate with the top 500 and the Green 500 to synchronize. And basically, all of those organizations, being volunteer organizations, to synchronize the work that's being done, because pretty much everybody's shooting in the same direction anyway. And so that's where we're at right now. We're looking at, eventually, we're considering of having just like you have the top 500 of supercomputers, the Green 500, maybe we could have eventually like a top 50 of the facilities, like what are the most efficient facilities. And so those are the kind of things we're looking for the months and the years to come.
So Nick, what is the call to action for the companies out there that are going to see this? What do you want from them at the Green Grid?
Well, basically, I think the first step is to raise awareness, right? A lot of CEOs and CFOs actually knew about the PUE because it was an easily understandable metric that had a direct implication on operational cost. So now it's about expanding the discussion, broadening the topic, and basically talking about, all right, well, you can have a PUE of 1.2, but what if you could have an ERE of 0.6 and actually saving 40% of your annual electricity consumption? That really rings.
Will help you focus on the right things to spend time and resources on, and not the stuff that's not going to matter much.
Exactly. And so first call to action, raise awareness, talk about it, and then definitely engage with your vendors about like the new alternatives to platform designs and cooling and liquid cooling, water cooling, etc. And warm water cooling, I was very happy this week to be in Hamburg. Warm water cooling is really becoming a hot topic, not to make a joke, but in the industry. And I'm really hoping to see the discussion transfer to SC11 in Seattle.
That was my wrap-up question. Is there going to be a session or a panel, or what? Is there something coming up?
So we're hoping to have a kind of a workshop set up at SC11 with speakers basically from both the research side and the academia, the vendor side, and we're hoping to actually bring some discussion around the large service providers. And the cloud providers that we know about around the world.
So I'm just guessing that when you guys do get together and you're going to develop a bunch of best practices, right? Cookbooks, that kind of thing. Is that in the future?
So already you can look at the greengrid.org. There's a whole bunch of white papers on data center design. You can get the white papers on PUE, RE, WUE, CUE, how to measure PUE, how to report it. There's already a whole lot of data that's out there, and I guess the first thing is to check it out and engage in the community.
Well, hey, sustainability in the data center. This sounds good. Well, thanks for coming on the show today. That's it from Hamburg. We'll see you next time.